What is multiple regression? Multiple regression is an extension of simple linear regression. It is used when we want to predict the value of a variable based on the value of two or more other variables. The variables we want to predict is called the dependent variables, while the variables we are using to predict the value of the dependent variables are called the independent variables.
The world is a very complex place. So, when we are looking to predict a value of a variable, oftentimes we can make better prediction if we use more than one variables to make that prediction. And that leads us to multiple regression. Two or more multiple independent variables are used or explain the variance in one dependent variables. Two problems may arise: overfitting and multicollinearity.
Let's move now to the overlifting and multicollinearity. Overlifting is caused by adding too many independent variables. They account for more variance but add nothing to the model. Adding more independent variable to multiple regression does not mean that the regression will be better or offer better predictions. In fact, it can make things worse. So let's move now to multicollinearity. Multicollinearity happens when some or all of the independent variables are correlated with each other.
The addition of more independent variable creates more relationship to each other. So not only the independent variables are related to the dependent variables, but also the independent variables are related to each other. So when this happens, this is called multicollinearity. So what is Minitab? Minitab is originally intended as a tool for teaching statistics. It's a general-purpose statistical software package designed for easy, interactive use. Minitab is well-suited for instructional application but also powerful enough to be used as a primary tool for analyzing research data.
What is Assistant Menu? In Minitab, the Assistant Menu is your interactive guide to choosing the right tool, analyzing data, and interpreting the results. If you're feeling a bit rusty with choosing and using a particular analysis, the Assistant Menu is your friend. Choose a regression analysis. Here's the problem. As part of a solar energy test, researchers measured the total heat flux. They found that heat flux can be predicted by the position of the focal points. We'll use the new features in the assistant to correctly position the focal points. In Minitab, go to Assistant, click Regression, and you'll see the interactive decision tree. You can click the diamonds for more information about how to choose and for examples of this analysis. We have 3x variables, or sometimes we call the predictors, and want to fit a regression model and to optimize the response variable. Following the tree takes us to optimize response at the bottom right.
Our response variable is heat flux, and the x variables are east, south, and north focal points. We've determined that we use a target heat flux value of 2, 3, and 4. But the assistant can also maximize or minimize the response. We also have the assistant to help us check for interaction effects and curvature. Click the Optimize Response button and fill in the dialog that appears with this information. The assistant takes our candidate x variables and produces a regression using stepwise regression. Let's take a look at the reports that the assistant provides.
Summary report. This summary report tells us that our regression model is statistically significant with a p-value less than 0.01 and thus an r-squared value of 96.15%, which is great. The comment section indicates which variables were included in the model. In this sense, if the model fits the data well, the equation can be used to predict heat flux for specific values of the x variables, or find the settings for the x variables that correspond to a desired value or range of values for heat flux.
The effects report graphically illustrates all of the interaction and main effects that are in the regression model. The lines are curved when the assistant required a polynomial term to fit a curve. For example, the east and the south interaction is significant, which indicates that the effect one variable has on the heat flux depends on the setting of the other variable. If south is set at a low setting 31.84, increasing east reduces the heat flux. However, if south is at high setting 40.55,
Increasing ease increases the
The diagnostic report displays the residuals versus fitted values and identifies unusual points that we should investigate. Based on the criteria of large residuals, expect roughly 5% of the observations to be flagged as having large residuals. So, the two that we have are not necessarily problematic. There are also 2 points with unusual X values. You can click the points so that you will know the row they are in the worksheet.
The model building report shows the details about how the assistant built the regression model, the regression equation, which variables contribute most information, and whether the X variables are correlated with each other. North contributes the most information to this model. East is not significant, but the assistant includes it because it is part of the higher order term. The assistant always watches you back. For example, when it builds your model, it uses standardized X variable because standardization removes most of the correlation between linear and higher order terms, which reduces the chance of adding these terms unnecessarily. The final model is displayed in unstandardized or natural units.
The prediction and optimization report shows the assistant solution for obtaining our targeted value of 234. The optimal settings for the focal points are east 382, south 31.84, and north is 16.01. For these settings, the model predicts a flux of 234 with prediction of interval of 216 to 252. The assistant also provides alternate solutions for you to consider using your subject or expertise.